Hello, I'm an avatar created by Yili Lin, a health services research PhD student at George Mason University. Today's topic is performing regression analysis in R. Regression analysis is a statistical technique used to explore the relationship between a dependent variable and one or more independent variables. Helps in understanding how the typical value of the dependent variable changes when any one of the independent variables is varied, while the others are held fixed. Use it to understand relationships between variables, predict outcomes, assess the strength of predictors, or adjust for confounding variables. We'll focus on two types of regression: linear and logistic regression. Linear regression encompasses models that describe the relationship between a dependent variable, y, and one or more independent variables, x's, using a linear equation. The goal is to minimize the sum of squared residuals. Simple linear involves one independent variable. Multiple linear involves two or more independent variables. Logistic regression is a type of regression analysis used for predicting the outcome of a categorical dependent variable, typically a binary outcome. Instead of modeling y directly, logistic regression models the log odds of the probability that y is equal to 1. This is called the logistic function, or sigmoid function, outputs the probability ranging between 0 and 1. Common assumptions for regression. The relationship between the independent variables and the dependent variable should be linear. The variance should have constant variance at all levels of the independent variables. Each observation should be independent of others. Check if residuals will be independent, crucial for time series data or data with potential serial correlation. The residuals should be normally distributed. This assumption is important for constructing confidence intervals and hypothesis tests. The independent variables should not be highly correlated with each other. High multicollinearity can inflate standard errors and make it difficult to determine the individual effect of each predictor. First step, preparing the data, reads the file into R and stores it in the data variable. Inspecting the data. Check for an address missing values, see handling missing values in R. Check assumptions to ensure that regression is appropriate for your data. More details in testing assumptions for regression in R. Step 2, performing regression in R. The LM function is used to fit linear models. Summary function provides detailed information about the fitted model. Multiple linear regression includes multiple independent variables. Logistic regression is used when the dependent variable is categorical, typically for binary classification, such as predicting whether a patient has a disease. The generalized linear model GLM function in R is used to fit a logistic regression model, allowing for multiple predictors. The family argument specifies that the dependent variable follows a binomial distribution, indicating a binary response. Step 3, data interpretation and validation. Check details in interpreting regression output in R. Conduct the post-analysis assumption tests, checking the residuals to ensure that the results are valid and that the assumptions underlying the analysis were met. See testing assumptions for regression in R. Linear and logistic regression have some similarities in validation, but there are key differences due to the nature of the dependent variable. In linear regression, goodness of fit is measured using R-squared, explains the proportion of variance in the dependent variable explained by the model. Adjusted R-squared is used when multiple predictors are involved. In logistic regression, no direct R-squared. Instead, use pseudo R-squared measures, like McFadden's R-squared. Cross-validation can assess how well they generalize to new data. K-fold cross-validation is commonly used to evaluate the model's performance and avoid overfitting. Linear regression uses mean squared error, or root mean squared error, to evaluate the accuracy of predictions. Confusion matrix is used to evaluate classification performance for logistic regression. Receiver operating characteristic ROC curve and area under the curve. AUC are unique to logistic regression, assess model performance in binary classification. Check details in interpreting regression output in R. Step 4, communication and reporting. Visualizing regression results helps in making complex data understandable and provides a clear picture of the model's performance. Scatter plot for linear regression to show the relationship between the independent variable and the dependent variable with the regression line. Probability plot for logistic regression to display the predicted probabilities of the binary outcome across different values of the predictor. When reporting the findings, it is essential to provide a comprehensive explanation of the results in a clear, structured manner. Communication is key to ensuring that the results of the analysis are understood and actionable. By following these steps, you ensure that the analysis is clearly understood, actionable, and can effectively guide decision-making processes.